So hi, today I'm going to explain what is OSI model and what is the TCP model and why do we actually use these models? Why can't we uh, use a single layer for all the network transfer? So using we use basically multiple layers because a single layer is not like robust and is difficult to manage. For example, if all the functions are performed in a single layer, for example, let's name X layer, the application presentation. If one breaks, all of them breaks, and we don't want that. And like many different layer, what can be it is easier to design and easier to debug also, and does not break others. So yeah, that's why we use multiple layers in the uh, network transfer model. So let's discuss the OSI model first. So OSI models mainly have 7 layers, whereas the TCP or IP model has 4 layers. So the difference between them is not that key. TCP OSI has extra layer. Instead, it has the three application presentation and session layer embedded, combined into one application layer, and the कहते हैं, transport layer is same, network layer is renamed as internet layer, and data link and physical are combined into a link layer, the final layer in the TCP IP model. So in real world, TCP or IP model is used more often because of its better speed. So what each of these layer does, let's discuss that. The application layer is basically the layer where we actually send a request like hypertext transfer protocol. So we send requests using an application. For example, Zoom send the HTTP request on the server for some data. Then the second layer is the presentation layer. So the presentation layer mainly takes care of the format. For example, if we want to transfer a video, so it has to be in the MP4 format. So it takes care of that, and it also encrypts the data so that it is secure and not like a vulnerable to hacking or other stuff like that. Session. So the next layer is session. So what this session does is it creates a session. For example, I create a Zoom call where I start the session. The meantime, the session is running and until the session ends. So what it does, it maintains a session so that if for some reason the connection is broken in between, it reconnects with all the data, and no loss is there, and so that key uh, there's a the connection is still there. So the next layer is a transport layer. So transport layer is basically where we divide the data into many segments. So it uses mainly two protocol, that is TCP, transfer control protocol, and the UDP, Universal Datagram Protocol. So what TCP does, it is connection oriented and works only when the connection is established using a two-way handshake or three-way handshake. So it establishes a connection and the data is sent in an ordered manner. It is generally slow because of this key. Without the previous data, it can't take in the new data. Whereas the UDP is basically a connectionless protocol. It is mainly used in things like video streaming, calling, or etc. Stuff like that, where all of the packets being present is not compulsory and can be avoided. Whereas in TCP, or for example, you are downloading a file, we need all the packets or the full file to be working correctly. The next layer is the network layer. So the network layer has a protocol that is IP. So it is basically it takes care of the routing between and the like the bounces. For example, there are many internet service provider ISPs. So like Airtel, Geo. So it takes care of through which uh, route the route the message or the packets are actually sent. The next layer is the data link layer. Data link layer mainly takes up care of the MAC addresses or the address resolution protocol. So it takes care of the adjacent node bounces and stuff like that. The final layer is the physical layer where the actual bits are transferred, because as we know, computer uses bits to transfer messages. So it is where actual transfer happens, for example, in form of wires, etc. So yeah, this is how data is actually transferred. For example, there is a sender one. It uses the application, then the message is sent to presentation, then session, then transport, then network, then data link, then physical. Then from physical, the data is sent to physical of the sender two. From there, the data goes from the network, and then it goes from physical of two to data link of two, then network of two, transport of two, session of two, presentation of two, and finally when it reaches application layer of two, the message is finally received on the other end. uh, for example, sender one and two are communicating through a Zoom call. So it goes from top to down, from sender one, and bottom to up for sender two. So, for example, let's give you an example. Suppose I search on Google. So what it does, it first it creates a HTTP request. Then the request is transferred into segments using the TCP protocol. Then the 1 second. Okay. Then the IP and source destination IP is configured, and finally in the data link layer, the MAC address is added. And when all of it is done in the physical layer, bits are actually sent as signals, and the Google is opened. Yeah, so that's it. Thank you.